Okay, so sometimes your log equations have more than one piece. So if your log equations have more than one piece, what you have to do is condense them into a single log first. So you have to remember how to condense into a single log. So the rule was, I have two logs right here. I can condense into a single log, so I'm going to write log base 3 and open my parentheses. This 2 is just sitting over here by itself. We're not touching that. The rule says if you're adding the logs, you multiply the terms. So I'm going to take x plus 4 times x minus 4. If you're adding the logs, you multiply the terms. So multiply here in the middle, I usually refer to that as FOIL. So I'm going to say that's the log base 3 of x squared minus 4x plus 4x minus 16. So that's the log base 3 of x squared minus 16, and that equals 2. Now then, at this point, I have condensed down into a single log. At this point, you have to decide, do you set pieces equal or do you make the circles that I referred to earlier? So the question that you're asking yourself now is, does every term have a log? Yes or no? Here you'll notice that this term does not have a log. Since this does not have a log, that means you make what I refer to as make the circles. So you'll say 3 to the 2 power equals this expression. 3 to the 2 power equals this expression. Okay, well 3 to the 2 power is 9. 9 equals x squared minus 16. Okay, so we have to solve this equation. You'll notice that it has an x squared equation. Well, the way we solve an x squared equation is to solve it by factoring. So to solve by factoring, remember you want to get everything to one side. So I'm going to move this 9 over. 0 equals x squared minus 25. Well, this is the difference of squares. I'll factor it, it's the difference of squares, and I'll set both of those factors equal to 0. Solve it out, but that is not my answer. The reason it's not my answer is that the directions say solve and check. Now, I didn't really stress the checking at the very beginning of the section, but I'm going to really stress the checking when you have more than one piece, especially when you have a negative answer. So I have two values here, negative 5 and 5, and I want to check. Now remember, you're not necessarily checking for correctness, you're checking to make sure you didn't take the log of a negative number. So let's try x equals negative 5. If you plug that back into the original, you get this, log base 3 of negative 5 plus 4 plus log base 3 of negative 5 minus 4 equals 2. So I would have the log base 3 of negative 1, and I can stop here. Okay? You can't take the log of a negative number. So you have to throw that problem out, throw that part out. So that's a bad answer. It actually is not an answer. It doesn't check. So then we'll go through it again and we'll check positive 5. if you're checking positive 5, you get the log base 3 of 5 plus 4 plus the log base 3 of 5 minus 4, and that equals 2. So this would be the log base 3 of 9, and this would be the log base 3 of 1 equals 2. Now, as far as checking for me goes, I'm making sure that when you take the log, you do not take the log of a negative number. This 9 right here is positive, so that's good. This 1 right here is positive, so that's good. So I would go ahead right here and say that x equals 5 is a good answer. It did not give me a negative behind any log. But some of you want to check it a little bit more. You want to check it all the way out. So you can continue to check this one here at the green step. Remember, the log rule says when you're adding logs, you multiply the terms. So when we were checking this one, which you don't have to go this far, remember when you add the logs, you multiply the terms. So this would be the log base 3 of 9 equals 2. Now, check it. 3 to the 2 is 9. So it does work. Now again, I'm just checking to make sure I didn't take the log of a negative number. So as soon as I got to this blue line step here, I could stop. But some of you, I know, wanted to check it all the way out. And that x equals 5 does check. Okay, so let's try another one of these. Okay, I notice with this particular problem, I have more than one log on the left side. So since I have more than one log, I have to condense it. I'm going to have a log base 5 of this expression. And on this right side, I already just have a log base 5, so I'm good there. I'll have a log base 5. I have one term there, one log. So that's all I need on that side. I'm good there. Okay, let's start back over. You have 2 logs on the left. You have to fix that. You have 1 log on the right. That's okay. If you have 2 logs, you have to condense them. When you add the logs, you multiply the terms. Okay? When you add the logs, you multiply the terms. So when you FOIL this out, you're going to get the log base 5 of x squared minus 2x plus 3x minus 6. Go ahead and simplify. At this point, I have a single log on both sides. That's what I need. At this point, you have to decide, do you make circles or do you set pieces equal? Since you have a log base 5 and a log base 5, all you have to do is set these 2 components equal. Of course, log base 5 equals log base 5, so what's behind them must equal as well. You have an x squared equation. To solve an x squared equation, you want to move everything to one side. When you move the 14 over, you get minus 6 minus 14. Now we have a regular x squared polynomial. We just want to factor it. The factors of 20 that subtract to give me 1 are 5 and 4. We'll set both of those equal to 0 and solve it out. That is not my answer, because remember, I have to check. Now feel free to check it all the way out, or you can just check it to make sure you're not taking the log of a negative number, whatever works for you. The first one I'm going to check is negative 5. If I plug negative 5 into the beginning equation, I get the log base 5 of negative 5 plus 3 plus some other stuff. Now I can stop right there because I get the log base 5 of a negative 2. You can't take the log of a negative number. So that means this value, -5, is bad. Okay, so then we can go about it and check the 4. I'm going to check x equals 4. So we're going to take the log base 5 of 4 plus 3 plus the log base 5 of 4 minus 2 equals the log base 5 of 14. Let me write it properly. So this would be the log base 5 of 7, positive number there. This is the log base 5 of 2, positive number there. And that equals the log base 5 of 14. Everything behind the log is a positive number, so that means this answer is good. Now for those of you wanting to check it fully, remember to combine two logs. If you're adding, you multiply the terms. So this would be the log base 5 of 14. You already have the log base 5 of 14 on the right. So that means that 4 is a good answer.